Okay, I know I said I'd see you in Lesson 4, but before we get into Lesson 4, we need to talk. So far, your part in this course has been pretty passive. I see you sitting there listening to me talking and watching me type and maybe answering a few questions now and then. And that's great. Trouble is, you can't learn to program a computer that way. Nobody can. Programming's a skill, and the only way to learn it is by doing it. If you've been following the advice that we gave at the beginning of the course and have typed in the same commands that I've been typing in, it shows that you're serious about learning this stuff. And that's good. That's a great first step. If you keep doing that, you'll get a pretty good idea of what computer programmers do. That'd be enough for a computer programming appreciation course. And there are courses out there that are pretty much like that. But that's not enough for this course. For this course, there's another step you have to take. Starting this week, you're going to begin this second step, the one that will actually teach you to be a computer programmer. To actually, be a computer programmer, you have to solve problems by writing computer programs. And that's the second step. And it's a big part of learning to be a computer programmer, and it's a big part of this particular course. When we say solve problems, we don't mean follow a step-by-step recipe that we dole out to you for each problem. We mean that we state the problem, and we stand back and let you cook up your own solution on your own with no help. If you've not quit this course yet, which come to think of it, you haven't, there's little doubt that you can learn to solve problems by writing computer programs. In other words, there's little doubt that you can learn to be a computer programmer. But the only way you're going to do it is to, do it. And we're going to give you a chance to do it in the form of weekly homework assignments, starting with week 3. These are programming assignments for you to write programs. We use the word homework because you do the work on your own, and that usually means you'll be doing the work at home. Of course, you may be doing the whole course on your own at home, but that's what we call them. Each one of these homework assignments consists of no more than 10 problem statements, and you'll solve each of these problems by writing MATLAB code. For each individual problem, you'll write one individual MATLAB function that solves that one problem according to the specifications given in the problem statement. In this video clip, you're going to see me solve example homework problems. I'll do everything that you'll need to do for an actual graded homework. That way you can see what's involved with the whole homework process. The solution that you'll create for each homework problem will be in the form of one single M file. So, for example, if there are 8 problems in, say, the third assignment, you'll create 8 M files for that assignment. We recommend that you create an empty folder to hold the M files that you create for the assignment, and I've done that with this example assignment. As you can see over here, I've got a folder, and I'm calling it HWX. Let's go up one level so you can see that. So there's HWX. And I double-click it so it's the current MATLAB folder. Here, X means example. You could make a folder named HW3 for homework 3, for instance, instead of HWX for example. First off, in this folder, you should put the PDF file that contains the set of problem statements for the assignment. Here it is, example homework.pdf. And you should copy the file containing the automatic grading program for the homework set there. We'll just call it grader, and here it is. For each homework assignment, you have to download a separate grader to your computer before you can use it. So you need to know how to do that. Links to both the grader and the PDF homework are given with every programming assignment, and they show up when you click the green button that says Start Homework Now. The grader for this example homework assignment is named HWXP. There's one grader for each homework assignment, and each one has a file name like this one, but with the X changed to the homework number. So for homework 5 here, For example, the greater is hw5.p. Now let's look at the problem set in the PDF. Every problem set begins with some general rules. They're up here in this purplish font here. Let's go over that a little bit. There's 4 items. First one says, unless otherwise indicated, you may assume that each function will be given the correct number of inputs and that those inputs have the correct dimensions. For example, if the input is stated to be 3 row vectors of 4 elements each, your function is not required to determine whether the input consists of 3 two-dimensional arrays, each with 1 row and 4 columns. It says, unless otherwise indicated. Later on, we will actually have you check in your function to make sure the input has the right form, but at first, unless otherwise indicated, you don't have to do that. Next, unless otherwise indicated, your function should not print anything to the command window. But if you have your function print something to the command window, it's not going to be a problem because it says, but your function will not be counted incorrect if it does. Next bullet point. Note that you are not required to use the suggested names of input variables and output variables, but you must use the specified function names. We'll look at this rule in a little bit on a specific example right here in number 1. Finally, read the instructions on the web page on how to test your function with the AutoGrader program provided and what to submit to Coursera to get credit. We'll go over that too. So now let's look at the first problem in the set. There are really only 2 problems in this set, and we're going to look at the first one first. Let's read it. It says, write a function called corner sum that takes a matrix M as its input argument and returns a scalar that is equal to the sum of the elements in the 4 corners of M. You may assume that the size of M is at least 2 in both dimensions. For example, MATLAB would assign 20 to the variable xyz if the function was called like this. So we see an example command xyz equals corner sum of, in other words, with the input argument, 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9. So this is a 3 by 3 matrix. And the 4 corners are the number 1, the number 3, which is the upper left element and the upper right element there on the first row. And then here on the bottom row, the bottom left or lower left position has a 7 and the lower right position has a 9. So the sum is 1 plus 3 is 4, plus 7 is 11, plus 9 is 20. So xyz would be assigned 20. Sure enough, we've got to write a function called corner sum that'll do that no matter what we give it as an argument. Let's start working on our solution by creating the M file for the function. To create the M file, you can click New over here on the left under this plus sign, but I like to use the edit command. You just give the name of the function. What was the name of the function? And we got to know the name of the function because if we don't use the exact name given in the problem, we won't get any credit. Okay, there it is, corner sum. Okay. There. You know, in fact, I think I'm going to rearrange things a bit so I can look at the command window, the editor window, and the PDF file at the same time. There we go. So, what do we do now? Well, we need to put a function header in here. Well, that's easy to begin with because we just type function and we get this keyword highlighted in blue. Okay, before we type the function name in there, we need to know whether this thing returns anything. Because if it does, we got to put an output argument here. So, functions usually do. Let's read the problem again. Write a function called cornersum. It takes a matrix M as its input argument and returns, there we go, returns a scalar. So like most function, it returns something, a scalar that's equal to the sum of the elements in the 4 corners. Well, it's the sum, so let's call it S. After that, we have to put an equal sign, and now comes the name of the function, which we can see right here, corner sum. And in parentheses, if this function takes input arguments, and most of them do, we need to put the input arguments. So let's see if it does. We read it again. Write a function called corner sum that takes a matrix M as its input argument. Yes, it does. And it says a matrix M. So that means there's just one argument. I mean, it's not saying like two matrices, three vectors or something. So it's suggesting that I call the input argument M, but I don't have to use that suggestion. It says so right up here. Note that you are not required to use the suggested names of input variables and output variables. So the input variable M doesn't have to be an M. I might use, say, I don't know, A. And just to show that I can do it, I'm going to use A. There. Okay, so that's the end of my function header. I'm going to hit return, and I'm ready to type the body in here. So let's think about the problem now. What do we have to do again? Return the scalar that's equal to the sum of the elements. So we have to compute a sum of the elements. Oh yeah, and the four corners of M. Well, we're going to have S set equal to this sum. And the first corner is pretty easy. The top left corner is element A1, 1. What about the rest of the elements? You know, if we knew this was a 3 by 8 matrix, we could do it this way. Because this would be on the first row, the left end, you know, that's the upper left corner, and then we have the last element on the row, because there's 8 columns in a 3 by 8 matrix, it would be 1, 8. And the bottom left is on row 3, element 1, and then the bottom right corner is the last row, 3, the last column, 8. That's great, but, you know, what if it isn't a 3 by 8 matrix? What do we do then? Well, one thing we could do is call the size function and get the number of rows and number of columns. M, comma, N equals size A. We'll put the number of rows into M and the number of columns into N. So, since this is supposed to be the last column, we make that an N. So suppose this is supposed to be the last row, we'll make that an M. And we'll do the same thing here, M and N. So that ought to work. So I think, but you know, wait, I got a better solution. How about this? So far it's the same, still the same, but instead of N, I put end. Because end is the key word that gives you the last element index in the position that you put it. So I put it in the column position, and it will change to this N, the last element of the column. And it works for the row too. And it works for both of them at the same time. So I've got two solutions, this one and this one. Well, which one to use? Which one's better? Well, neither. It makes no difference. I think I'll stick with, I don't know, this second one because it's one line instead of two. Let's get rid of this first one. But really, it makes no difference. If it works, it's right. So, I guess we've got this problem solved. And we probably have solved it since this is a one-liner. But I can tell you from experience that my first try on these problems is usually an abysmal failure. And I got 40 years of experience. So before we even think about saying our solution is correct, we need to test it to see if it is. And by test it, I mean making up inputs and calling it directly from the MATLAB command window with those inputs and looking at the outputs. I don't mean running the grader. The problem with running the grader is it doesn't tell you enough. In the very rare cases when you'll get the function right without any testing, it'll tell you it's correct. But in the vast majority of cases in which you don't get the function right, all it'll tell you is the arguments that it succeeded on and the first argument that it failed on. That helps a little, but there's no hint about why it failed. You'll get no information about that if you don't run the function yourself. But if you run tests in the command window, MATLAB itself will always tell you, for example, if there's a syntax error, and it'll tell you the exact line it's on. And there are a lot of semantic errors it'll identify too, like trying to use a non-existent variable or using an index that's outside the range for some vector or matrix you've got in there. You don't want to give up all this free help. And if MATLAB doesn't report any errors when you try your test, you'll see the value that your function returns and you can check it to see whether it's correct or not. So, let's test our function. Well, to do that, we need to give it a matrix. We know it needs to work on the example given here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's do that one. Answer's 20. Yep, it says it would assign 20 to the variable xyz, so it works great. But that's just one example. You'll usually want to make up lots of examples to test it. Let's try this one. So you may remember that ones gives you a bunch of ones. And when you give it one argument, it means like with a 3, it means 3 by 3 ones. And so let's see, each corner is a 1. There are 4 corners, so the answer should be 4. So let's try that. And we get 4. More good news. Well, let's just try another one. That's a 2 by 5 matrix, and the corners are 1, 5, 6, and 10. So 1 plus 5 is 6, plus 6 is 12. 22 should be the answer. Let's see. $22. Okay, that's looking pretty good. Now let's try one more here. X equals... So we got 1s, 2s, and 3s. The corners are 1, 1, 3, 3. So that should be 8. So let's set y equal to the result. 8. This thing's looking pretty good. I'm confident now. But before we run the grader, let me emphasize an important point. The input to the function, that is the various matrices we use to test our function, were created outside of the function, not in here. Over here in the command window. For example, on the last one, we had a variable x in the command window that we'd given a value. When we call our function, right here, MATLAB passes the value that's in this variable x, which is a 3 by 4 matrix of 1, 2s, and 3s, into the function. Inside the function, the input argument a is assigned a copy of this matrix. The one that was in X, but it's just a copy over here in A. Then the function goes to work, does what it's supposed to do with it, assigns the value that it gets to S, which we've made an output argument here. And then the function returns. And when it returns control to the command window, this value that's in S, which happens to be 8, is copied over here, and it's assigned by the command window to y, so y gets the 8. And the value is exactly the sum of the corner elements of the original matrix X. Perfect. Before we go on, let's look at a couple of typical mistakes made by beginning students. A mistake we've seen many, many times is to create the matrix inside the function. You know, like this. And they'll often put the exact example that was given in the problem. Don't do that, because every time the function's called, a different matrix is supposed to be assigned to A. We don't want to copy over that value that was assigned to A with this same value every time. We'll get the same answer every time, right or wrong. So let's just go back and call it with the very first example that we did, that we got out of the problem. You might do that, and you look at the answer and it says 20. You think everything's copacetic. It's great, worked just fine. Well, let's try it with one of the other examples that we had. What's this one? We get 20. Remember, the answer was supposed to be 22 for this one. And now let's do the one with the x. 20. That's not the right answer. That was supposed to be 8. We're getting 20 every time because we're clobbering the A that was copied from the command window into this argument here with our matrix that we defined inside here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Friends, we can give this thing input after input until the cows come home, and we're going to get that same monotonous 20 as an output every time, right or wrong. And I can tell you the grader won't like it. Okay, let's get rid of that. There. Another common mistake we've seen just as many times is to print the result of the calculation directly to the command window from inside the function, instead of returning it through an output argument. Let's go ahead and make that mistake. I'll first remove the semicolon from this statement right here, which will cause the result to be printed directly to the command window. Then I'll remove the output argument from the function header up here, so the function doesn't return anything. Now let's run the function again. Let's see, we had x here. Yeah, let's call it with x again. Well, it returns 8, or it looks like it does, so it may seem to work. It's kind of strange, though. When it returns something, it doesn't usually say s is equal to 8. It's saying s is equal to 8 because that's what it does when you leave the semicolon off an assignment to s. But you might not notice that when you were testing it. Let's try assigning it to a variable like we did before. Oh my, we got an error this time. It says error using corner sum, too many output arguments. The phrase too many output arguments means that we've given one output argument here, the y, when we called it, and 0 output arguments here when we defined it. You know, 1 isn't a lot, but it's 1 too many compared to 0, so MATLAB is complaining. Okay, let's hit undo a couple of times to get rid of this mistake, the print instead of return mistake. Now let's try this command again. This time it works fine. We calculate the value of s, we don't print it to the command window, but then we return it and it gets assigned to y. Now we've tested and debugged our function and we're ready to test it with the grader. Are you excited? Okay, it's not that exciting, but it's necessary to get a good grade, so maybe that gets you a little excited. To run the grader, let's make sure it's in the current folder. Yes, here it is, hwx.p. We run it by typing its name without the .p, just as we would run an M file, you know, by typing its name without the .m. So here goes. So we have this basic menu here. Let's see. If we type a 0, it'll exit. If we type 1, it'll test corner sum. If we type 2, it'll test total weight. If we type 3, it'll test all the problems. Then it gives a score and a submission code. We'll talk about that later. Up here, it's reminding you that nothing is being submitted. You can relax. This is not going to be graded. The testing that we're doing right now is not done by the outside world. So anyway, let's just try testing corner sum by typing a 1 and hitting return. Well, it says your solution is correct, which is what we were hoping for. It also gives what it calls feedback. Let's look at that. As we mentioned earlier, this is just the set of arguments that it tried. Got The last one's a long one. Good night. As you can imagine, these arguments have been chosen carefully to test most of the errors that students are likely to make. But if it fails on any of these arguments, as we'll see in a couple of minutes, it won't tell you why, and it won't tell you what the next arguments are that it's going to test on. Both of these pieces of information would make it far easier for you to debug your function, but the emphasis in these homework assignments is for you to practice and improve your own debugging skills by coming up with your own examples. Wait, I know what you're thinking. You're thinking you can look inside the grader function to see what the test cases are. Well, you naughty, naughty thing. Sorry, no can do. This is a P file, and P files are encrypted. And this is bazooka-proof encryption, so there's no way to hack into one of them. Hey, it's like I said before, in this course, you're graded on your ability to solve problems by writing a computer program with no help from the people who ask you to solve the problem. You know, like a real computer programmer in the real world solving real problems. And a big part of solving a problem is testing your solution. Of course, this is not the real world, but it's as real as we can get it. Okay, back to using the grader. Let's run the grader again, but ask it to grade all of the problems. So we type HWX, hit return again. And we'll select 3 for all the problems. Well, corner sum passed again, but total weight was, of course, not found. That's the message right here. Anyway, the bad news is that our grade here is only 50%. But the good news is that we're already 50% done in this homework. Well, this was so much fun, let's do this again. But this time, let's see how the grader reacts to mistakes, and then show how we might find them and correct them. Let's start with the first error we made before when we were, putting our own matrix inside the function. So let's pull this thing over here a little bit, and remember we did this? There, we knew that was the wrong thing to do. We did it anyway. And this time I think I'm going to forget the input argument here. And I don't remember this end keyword, it turns out. So let's just put the actual number in here, 3. This is a 3 by 3 matrix, so these are all 3s. There, that should do it. So let's try this thing. Gives me the 20. Remember, I'm supposed to get a 20. Of course, I didn't give it an argument, but, we're making mistakes here. So we're ready to run the grader. Let's see how it reacts. We're going to run it on corner sum, so we select number 1. Your solution is not correct. What's going on here? 20 is the correct answer. This grader must be wrong. At this point, you're ready to fire off a post on the discussion forum. Something like maybe this. Title, HWX, Problem 1, Grader Error. Body, my function works correctly. It computes the correct answer 20 for the example, yet the grader says it is incorrect. What is wrong with your grader? There we go. Feels good. Now, try to imagine somebody reading your post. That person has no information other than your claim that your function works correctly. But of course, your function is incorrect. In fact, it has 3 major errors. But that other person can't help you because you didn't provide any useful information. So what information should you post? Well, first off, there's something that you should not post. You should not post the code from your function. In fact, you must not post any of the code from your function. We don't allow that. In fact, we don't allow anyone to post any code in any of the forums, regardless of whether it's correct or incorrect. Instead of posting code from your function or saying that your function is correct, you need to run the function in the MATLAB command window and copy both the command and the output into the post so you can prove to the reader that your function's working correctly. Let's do that. Our perfect function may not be perfect after all. Kind of wish I hadn't posted that complaint now. The phrase too many input arguments means that we're trying to input an argument here when we call our function, but we didn't include an input argument in the heading here where we defined the function. So that tells us we need to add an input argument in the editor window like this. So let's put it here. There. Now let's try it. Perfect. Okay, let's run the grader. So now we passed the first test, but fail the second. How is that even possible? Yeah, I guess I was right. That grader is definitely bogus. Don't these guys test the graders? Sheesh. Here, I'll run it in the command window. With the same exact test case. Let's see what it is. Just to prove I'm right. So let me just copy this thing. There. What? Wait, 20? Should be 10. 1 plus 2 is 3 plus 6, 10. Let's look at our function in the editor again. Well, as we said before, we're making the error of setting the matrix value inside the function on this second line. We're simply overriding the input argument. That is not good. Let's say it one more time for emphasis because we see students make this particular error so often. You do not create a value for the input inside the function. Ever. Never do that. The input is already given to the function by the caller over here, and that's copied into A. MATLAB is even telling you that this is a mistake by painting the A with this mustard-colored highlight and by giving you the tip when you hover the mouse over the A that input A might be unused. Well, that's exactly right. The input is unused because we're erasing it and putting our own value there. The grader was calling our function with that 2 by 2 matrix, and we ignored the input and changed the value to a 3 by 3 matrix. Big no-no. Did I mention that you should never do that? So let's delete that line. And let's run the grader on this one again. What? It's still not correct? Okay, we made a common testing error here. We ran the grader immediately after the last change. We should have tested the function directly first. So let's test it directly. Attempted to access A13, index out of bounds because size A equals 2, 2. Error in corner sum line 2. Let me click that. Takes me right there. Yeah. That's right. We typed in those 3s here for that first test case. Typing a special case into the code like that's called hard coding. We hard coded those 3s in there. Oops. Well, what we need is the last column here, row and column there. Now, how do we do that? Psst. Okay, look, I'm just pretending that I don't remember the end keyword here, okay? So remember the size built-in function that tells us how big the matrix is. That's cool. That's exactly what we need. Let's do that. Now, M will get the number of rows, and N will get the number of columns. So we'll put N for the number of columns here, M for the number of rows, M, N. So, ready to run the grader? No, we've learned our lesson. We're going to test the function ourselves this time. correct. Cool. Let's test with another one just in case. See if that's right. 2 plus 2 is 4. 4 plus 4 is 8. Yeah, right. Okay, 12. Excellent. Now we're ready for the grader, finally. Let's test 1. Solution is correct. Hooray! We did it again. But even more importantly, we learned a few lessons. 1. We do not change the input argument when we pass a value from the command window. 2. We must assign the result back to the output argument. 3. We should test multiple times with different input arguments directly in the command window to catch errors before running the grader. And 4. If we still can't figure out what's wrong, we can post in the discussion forum, but we provide the result from running our function directly from the command line when we do that. And we should do that as a last resort. And when we do it, we should also provide additional information by running these commands, including the input the grader fails with, and copying and pasting the entire output provided by MATLAB. We should include all that, but we should not include the code. Now let's do the next problem. Let's read it. I need a little bit more room here. Write a function called total weight that has as input arguments 2 row vectors of the same length. Each element of the first input vector, called vol, specifies the volume of an object made out of a certain homogeneous material. Each element of the second input vector, called wd, specifies the weight density of the material corresponding to the element in the same position in the first input vector. The function has 2 scalar output arguments. The first, called tw, is the total weight of the objects. The second output, called tv, is the total volume of the objects. For example, if vol is equal to 1, 2 and wd is equal to 1, 0.5, then executing the command, and you can see it there, wv equals total weight of vol wd, would make w equal to 2 and v equal to 3. Well, let's see if this makes sense now. Okay, so the first element here is the volume of something, and the first element here is the density of that same something. So if you want to find out how much that first one weighs, you'd multiply the volume, which is 1, times the density, which is 1. 1 times 1 is 1, okay? And if you wanted to know the weight of the second one, it'd be 2 times 0.5. 2 times, that's also 1, so I guess both of them weigh 1. Now, TW is the total weight, so the total weight would be 1 plus 1, that'd be 2. And the volume, total volume, well, that's easy. The total volume is 3. Okay, I see. All right, so that's what we got to do. But of course, this is an example with just 2. It could be 3 or 5 or 35 or whatever. So we got to get started. Let's create the function file first. This time I'll use the toolbar and the create new function command that's right here. Let's see, somewhere there's the new function command. I create that, and it's called untitled. And it gives me the keyword function, so I don't have to type that in. It's already put brackets here, and it says put the output arguments there. And then untitled, that's the name of the function. Well, we want it to be, what was it? Total weight, let's put that in. And let's put our output arguments. What were they? The TW and TV. Oh, yeah. So we got that. And the input arguments, got to put those in. Those were, they suggested vol and WD. This time I'm going to use the ones they suggested. Doesn't really make any difference, but we're going to do that. So, good. Let's delete the comments for now. and we're ready to solve this problem. Okay, so we figured out when we read this that we basically have to multiply the volume of each element with the corresponding density element to get the weight. So we have to multiply the corresponding elements and add the product together. Something like maybe this. That'd be the first volume times the first density to give the first weight. That's the second volume times the second density. We don't know how many of these we've got. We can't be, I mean, what if they give them a 500? We can't be typing 500 in. MATLAB works very well with matrices and vectors. We need to multiply corresponding elements of two vectors of the same length. Well, that's exactly what array multiplication does. So we can get rid of all this, and we can say x equals vol dot star wd dot star wd. That'll do it. That'll multiply the first element times the first element, the second element times the second element. So now we'll have a vector, and each element of this vector will be the product of the volume and the weight of the corresponding element. So each element of x will be the weight of one object. Now we need to sum that up. Well, that's what sum does. So the total weight is equal to the sum of x. In fact, we don't even need x, now that I think about it. We could do this. Just move this whole thing. I'll cut that, and I'll paste it right there. Pretty neat. One-liner, at least for the total weight. And don't forget this semicolon. We don't want MATLAB to print the value here. So are we done? No, wait a minute. We have a second output, the total volume. Well, that's another job for the sum function, only this one's even easier because we just, wait a minute, TV's total volume. We just sum up the volume. So that's it. Let's try it. Let's come up with a value in the window here, command window. For volume, we'll make it 1, 2, just like in the problem that we're given in the homework set. And the same density. And now let's try it. So we're giving it V. V will be copied into vol. D will be copied into WD. The answer will come back, and we'll see how it works. Oh. We have to save this thing as whatever name we want, total weight. So let's do that. Here's the save button. Let's save it as total weight. It even suggests that because it got that from the name of the function that we put here. So let's try this again. Let's see, that's correct. Weight is 2, but where's the total volume? We're supposed to get that. Who stole the total volume? Well, nobody did. We didn't ask MATLAB to do anything with the second output, so it just silently swallowed it. We've got to ask MATLAB to save that second output too. Now, is that done? Well, it's easy. Let's do it this way. So everything's the same, but this time we've got two arguments in brackets over here. And WW is 2, so the total weight is 2, and the total volume is 3. So that's correct. Perfect. Time to run the grader. Let's try the second problem only. I'm so excited I can't type right. There. Solution is correct. Now let's see how we did with the whole thing. We'll do 3 for all problems. Solution is correct. Let's scroll up here. Yeah, remember that? We got problem 1, we got problem 2. Score 100. We are off to a good start here. And of course, there's this alphanumeric code. That is what we submit online. And the instructions are there on the homework page. And when we submit that, then we're finally telling the world whether we did okay with them. That'll be translated and you'll get the score 100. There's one more thing, though. Any non-trivial problem can be solved multiple ways. So could we come up with, say, another approach here? Let's see, we need to sum the element-wise products of 2 vectors. This sounds very familiar. Anybody remember matrix multiplication? I think we're on the right track, but for matrix multiplication, the inner dimension must agree, and here we have 2 row vectors of the same length. What if we transpose the second vector? That'll make WD a column vector, and of course vol is a row vector, so the inner dimensions are the same, their length. Whatever that length might be, they're supposed to have the same length, of course. And we're supposed to be able to assume that whatever specification of the inputs was given here is being followed. Remember that? Scroll back up here. Unless otherwise indicated, you may assume that each function will be given the correct number of inputs, and those inputs have the correct dimensions. And the correct dimensions here are that they're both the same length. Of course, we've already used that when we did this array multiplication, but it's worth mentioning. So, back to what we're trying to do, this second method. TW is equal to vol star WD prime. WD prime is a column vector, so it's 3 by 1, for example, if it's 3 elements, or 5 by 1, or whatever it is, n by 1. And vol is 1 by n. 1 by n by 1. The inner dimensions are both the same. And what's the results dimensions? Well, 1 by 1, which is a scalar, and it's equal to the total weight. So now we don't need that first sum function. So let's get rid of this. Now let's run a few tests. Let's do this last one we did. Now we got everything correct. And maybe one more. Well, let's see here. Let me think. Each vector is 1, 1, 1. Sum is 3. Sum of the product. Yeah, okay, that's correct. Okay, now we're ready for the grader again. Let's see if I can type it right this time. And let's go for broke. Everything's correct. We made another 100. There's that alphanumeric code that we can submit. But just a reminder that we should always test in the command window instead of going immediately to the grader. Here's another example of why. Let's make a simple syntax error here. Suppose we accidentally typed VOLL, vol, instead of VOL. It's an easy mistake to make and easy to miss. Now let's run the grader. Pick 3. Your solution is not correct. It doesn't give you any hint that there was a syntax error. It tells you what it was tried on, and you look at your code and you think, oh my gosh, that's great. MATLAB is giving you a hint right up here in the editor, which you might miss. This yellowish mustard color highlight with a little squiggle says input argument vol might be unused. Yeah, it's unused. It's vol, O-L-L, is not used anywhere, just vol. So that should give you a hint. But of course, if you run it here, let's run it, the last thing we did. Then it says undefined variable function or variable vol, line 2. Now it turns it around and it doesn't know that this is wrong. It thinks that maybe that was right and this was wrong. But anyway, once you look at that, you'll figure out what the problem is. But let's suppose you get this working. And you want to tell somebody in a post that you might be having trouble. You want to ask them questions about that. If you can't figure out what's wrong with your solution on your own and you've tried hard to do it on your own, you can go ahead and ask a question on the forum. But when you do, provide as much information as possible. One way to do that is to run the function and catch the outputs and the output arguments, and then run who's on those output arguments and display their values like this. Let's do one differently here. Let's do this. Okay, there's the output. Now let's run who's on these. This shows the size of the variables and the types and stuff like that. That might be handy for somebody you're trying to explain this to. And then let's show their values by typing them with no semicolons. There. Then you can copy all this and then paste that into your post. Title, HWX, Problem 2, Trouble. Body, I can't figure out what's wrong with my solution. Here is what it looks like when I run it. Now I'm going to paste this in here. And there you go. Just remember, we do not allow you to include code in your post. Okay, so now we've really told you everything we can about doing the homework. You're ready to tackle the first programming assignments of the course. If you follow our advice, do the things we told you, you're probably going to do pretty darn well. So let's get started, and good luck.